Hello and welcome back. This is part 3 of the OSPF configurations. In the first two videos, we have configured the interfaces, we removed the existing configurations in the routers, and we prepared for OSPF configuration. Now, we're going to advertise this network from router here, and then advertise to the rest of the networks. We do the same for that router, which will advertise that network to both router 2, router 1, and router 3. So let's start. And this is one subnet connected to R1 and one subnet connected to R1. If we want to advertise both, we can just connect to the command line and then go to the enable mode, then config terminal. And in here, we say router OSPF, and then you have to create process number, process ID. You can choose any number, and they don't have to be the same across the routers. It's not autonomous number, which has to be the same, but for OSPF, it's a process number, which is only locally significant in this router. So let's choose 10 or 1. You can start from 1, OSPF 1. Let's do that. And now we are in the OSPF configuration. And in this router, we have two networks to advertise. One, which is 10.1.1, another one, 20.1.1. So we'll say network. And then if you put question mark, it will tell you what to put there. It's the subnet. So 10.1.1.0. And then if you put another question, it's the wildcard bits. To calculate the wildcard bits, you have a subnet mask, which is /24, which is 255.255.255.0. If you subtract 255, 4 octets, or each one is 255. If you subtract from your subnet from there, then you will have your wildcard mask. So in here, we will have 255 minus 255, which is 0. And then 255 minus 255, which is 0. And then 255 minus 255, which is 0. And then 255 minus 0, which is, because the /24 will have 0, that will be 255. And then you need to define the area. So area, and the backbone is the first one we have to create. It's called area 0. And that network is now done. We completed this side. Let's advertise from router 1 again, that subnet, and then we say network, and that's going to be 20.1.1.0, and the subnet mask is /24, so the wildcard is going to be 0.0.0.255, and that's in area 0 as well. For that router, we're all done. So we save the configurations, and then if we now say show IP protocols, show IP protocols, then it tells you we have OSPF 1 and we're advertising these networks. It tells you a lot of information you need later when you want to troubleshoot your routing protocols. You would use this command. But for this, it's complete. We go to router 1, router 3, one subnet over here, one subnet over here, one subnet over there. Let's do each one separately. So enable mode, config terminal mode, conf t, and then router OSPF 1, and then we say network. The first one is the one connecting with R1, which is going to be 20.1.1.0. The wildcard mask is going to be 255.0.0.255, and then area 0. Then we're going to advertise that network, which is network 10.2. Okay, so tab key if you are interrupted by the command line or the syslog traffic. So 10.2.2.0, and wildcard mask is going to be 0.0.255, again area 0. And then we are done with that network. We're going to do this one, 20.2.2. so again, same command, 20.2.2.0, 0.0.0.255, and again area 0. And this router is now complete. If we say show IP protocols, then you will see the 3 subnets we are advertising are all here. Then we go to the third router and configure the same. We go to the enable mode and then config terminal mode, and then we go to router OSPF 1, and then network we are advertising. If you see from here, we have 20.2 and 10.3. So let's advertise both of them /24. So 20.2.2.0, 0.0.0.255, again area 0. Then network, which is a local LAN, 10.3.3.0 and 0.0.0.255 area 0, and then if you say end and then save it, if you say show IP protocols, there's a lot to learn in IP routing, dynamic routing, but for now we just want to get the basic connectivity, understand the basic construction of OSPF. So now this subnet will be known to this router, even though it's not directly connected, via this router 2. So if I go to here and if I say show IP OSPF neighbors, if I do that, then it says my neighbor is this router and 20.1.1.2, which is the IP 20.1.1.2, and my ID is this. The ID, it chooses the highest IP address, or if there's no loopback. If you have a loopback, it will use the loopback IP, unless you statically create a router ID in the OSPF configurations. So now if I say show IP route, you can see 10.3, which is actually far from us, which is in this subnet 10.3, we can reach them from there. Even that one will reach it because router 2 knows about that. So you can see that subnet is known through OSPF. We also know the 10.2.2 through OSPF, and 20.2, which is between R2 and R3, that's also through OSPF. That means this router can have full connectivity to here, to here. And if you now check R2 and R2, then previously we had only the connected subnets, but if we say show IP route, then you will see we can see the network 10.1 through R1, which is the IP. We can also see 10.3 through router 3, and these are the only two OSPF. This is connected to R2, this is connected, and it doesn't need another router to advertise that to it. The only thing she does, that he or she, whatever, this one doesn't know it is here. Router 2 does not know this IP. It's not directly connected, but it's learning through R1. And also 10.3, it's this router who is advertising to R2, and R2 knows this network by learning from R3. So the networks are all in place. If we go back to the ping we tested previously, which was showing unreachable, if we use up arrow, we are pinging the same IP we couldn't reach previously. This should work now. So we wait, maybe we missed the first one or the two, then it should pick that up. Now that's working. You can see we can reach. That connectivity is set up. There is a website there. We don't know the DNS yet. Actually, the DNS is there now. We have a route to reach that. So we configured this device to have a DNS IP, which is this, which it can reach. So if you go to the browser and use the IP or the name for that, we should be able to reach. So testpage.local, we should be able to reach that interface. Okay, that took a little longer than we expected. Let's ping if we can actually reach, because we know the configuration allowed us to reach the ping 10.3.3.101. Can we reach that? Yes, we can. And then ping 10.3.3.100. We also can reach that. Can we reach the DNS machine? Ping 10.1.1.100. Yes, we can reach. So why it's not pinging? Maybe it's just slow. You need to be patient. Let's try again. Okay, we do the test again. Test page.local, and there you go. So thank you very much. You have OSPF fully working end to end.